could be something else. So that's why it's written as A, but A could be also gravity. Gravity. If it's just going straight down without, and you didn't push the object down. So times the time that it took to travel squared. So say you didn't push an object, you just let it down, and you want to know how long it traveled. If the acceleration was just 9.8 meters per second, and you want to know how long it traveled for 10 seconds, right? So 10 seconds squared. So then you would just put this into your calculator, whatever that is, and that would be the distance that that object took to travel. Let's see. Graphs of motion, I don't know. Okay. So let's look at the alright, so let's look at graphs of motion. And on page 23 they have the speed versus time, and they have the distance versus time. For figure 2.9, if you look at the example, we have speed and we have time. As the time increases, the speed increases. And you can find the acceleration by doing the slope. So the slope is the acceleration, because, as you know, acceleration is the change in speed over the change in time, right? Now the distance versus time, so this is distance and this is time. Okay, so this is figure 210. Here it's just saying that as time increases, the distance is going, the distance travel is faster and it's faster, right? It's increasing very, very fast, the distance traveled. Well, this means that the slope is getting bigger and bigger, right? This is a small slope right here. Let me use something different. This is a very, very small slope. This is a bigger slope. This is a huge slope. Here, the slope is velocity. Because, as you know, velocity is the change in distance over the change in time. So this means that there's an increasing velocity. So velocity is going up. Let's see. And that's pretty much it for chapter 2. I'm going to do a plug and chug problem. So let's see. I'm going to do number 26 on page 26. It says calculate the average speed of a cheetah that runs 140 meters in 5 seconds. Remember that velocity is equal to the change in distance over the change in time. So the change in distance goes from 0, goes from 140, and the change in time is 5 seconds minus 0. This is the end time, this is the initial time, end distance, initial distance. This is just equal to 140 divided by 5, and I don't know what that is. So whatever that equals to, that's the answer. Number 27. it is calculate the average speed in kilometers per hour of Charlie, who runs to the store 4 kilometers away. 4 kilometers away in 1 hour. So the velocity in kilometers per second, in kilometers per hour, is just a change in distance over the change in time. So it's just 4 kilometers in 1 hour. So that just means that it's 4 kilometers per hour. Number 28. It says calculate the acceleration of the car in kilometers per hour per second. That can go from rest, and rest just means 0 to miles per second to 100 kilometers per hour in 10 seconds. So here, acceleration, remember, is the change in velocity over the change in time. So this is just 100 kilometers per hour divided by 10 seconds. This is just 100 kilometers per hour times 1 over 10 seconds. So this just equals to 100 kilometers over 10 times hour times second, which is just 10 kilometers per hour times second. Okay. Okay, number 33. I'm gonna skip a couple. Number 33 says calculate the instantaneous speed in distance fallen for an object that falls freely from rest for 8 seconds. So the time is 8 seconds. This is a free fall problem. We want to know how fast and how long. Okay? Remember, how fast is v equals gravity times time. So that's just 9.8 times 8 seconds. And whatever that is, whatever 9.8 times 8 is, okay, meters per second squared. Don't forget the units. And how long? Remember, this is just going to be the distance equals 1/2 times the acceleration times time, I believe. Time squared. Acceleration times squared. So this is just going to be 1/2 times 9.8 meters per second squared. This should be meters per second. Sorry, I'm going to explain why that is. And then this is time, so that is 8 seconds squared. Okay? So let me explain what I did wrong here. So in here, I should have 9.8 meters per second squared. That's my gravity. And I'm multiplying it times 8 seconds. Well, I have seconds here, I have seconds here, so my answer should be 9.8 times 8 meters per second, right? Because I have the second here, I have this meters here. Here, we're going to have 1/2 times 9.8 times 8 meters per second squared times second squared, right? Because they're squared here. Oops. So this is squared as well. So I have second squared, I'm left with meters, which is the distance, so that means that I'm correct. I'm gonna stop it right there.